This is this is how the stuff gets made. Hey everyone, welcome to the Swift Kick Show. My name is Kevin Griffin. Very pleased to have you join us today. We are coming live from multiple avenues. We are live not only in Webinar Jam right now that a lot of our live folks will be coming in from, but we're also live on Twitch. And we're actually working on the process of moving this show to Twitch only, so you can visit us from anywhere. If you're new to the Swift Kick Show, welcome. I try to do this every 2 weeks. We focus on a lot of Microsoft and web-centric topics. So today I'm going to talk about ASP.NET, going to ASP.NET Core, and but we have other talks in like Azure and anything Microsoft or web related. If you'd like to be on the Swift Kick Show, I'd love to have you. This is a great avenue that if you are getting started in speaking and you just want to try some new material, let me know. I will provide this system for you to come and chat with me and teach me something new and teach all the good folks out there. So if you're coming in, say hi in the chat. I would love to know who you are, who's out there. And if you have any questions throughout the session, let me know. And typically I have a guest. And today's a special day. I don't have a guest. I was looking at the lineup and I had a couple maybes around this date and decided, you know what, I'll just do it myself. I did this particular talk 2 weeks ago in Knoxville. I'm sorry. I did this talk last week in Knoxville, Tennessee for CodeStock. And I was doing prep for it 2 weeks ago. That's why I had 2 weeks stuck in my head. And it went really well. I'm super happy with the way that it turned out. And I decided, let's just do it again for the good folks out there who were not able to make it. And so here we are. Well, there's no real fancy introduction. I'm going to share a screen. And those of you out there on the Twitch, you're seeing everything get made. Oh, yeah. So let's move Kevin off the screen there. So again, say hi in chat. I'd love to talk to you. All right. Making sure everything's all set. It is. Let's hit F5. Let's go live. All righty. So let's hide that guy. And for some reason, the Twitch folks are seeing my taskbar. So let's hide the taskbar. There we go. Taskbar's gone. Excellent. So Sheldon, I see you out there. Hope you're doing well. Glad you made it at the right time. I don't know what that hiccup was about. We were listing the wrong time on our website. And for some reason, it said 11 a.m. when it should have said 2 p.m. One of the things that we try to do is we put the dates in and we do conversions for based off time zone. So when you come to our website, the time should be reflected in your time zone, not in the venue or the event time zone, which can cause some problems sometimes. But oh well, we hopefully got this straightened out. Anyone that comes late, they'll get the replay, or they showed up early and they had a countdown that said it was coming soon. So let's jump into it. This is upgrading your ASP.NET 4.0 plus skills to ASP.NET Core. I came up with this talk because I've been converting a good number of ASP.NET applications from legacy ASP.NET. I'm coining that term, legacy ASP.NET. It's basically anything that's on the .NET Full framework, and moving that to ASP.NET Core. I'm pretty sure someone out there on the ASP.NET team would get mad at me, but it's how it goes. Notice I'm not calling it classic ASP.NET. I threw that one around too. Let me know in the chat what do you think? Should it be legacy ASP.NET or classic ASP.NET? Can go either way. Those who don't know me, my name's Kevin Griffin. I own SwiftKick. We're a training and consulting company from Chesapeake, Virginia. I'm a Microsoft MVP, the host of the Two Frugal Dudes podcast, and I also run this amazing conference in Virginia Beach, Virginia called Revolution Conf. I would love for you to come out and make it. We still have tickets available June 6th and 7th this year. And it's literally right on the beach, hotel, beach, hotel, beach. You can't get any better than that. I have email and Twitter. I would love to talk to you afterwards if you have any feedback at all or any questions. And Matt, ye old ASP.NET, I'll try that one out and see how it goes. That's not a bad suggestion. All right. So I left my slides in from CodeStock, but I have a webinar that, I have a mailing list that you can get more information from. You can just reuse the CodeStock one if you'd like to find out more. The folks in Webinar Jam are already getting this information, but anyone out there on Twitch or on YouTube, you can go here as well and get on our mailing list. We'd love to talk to you. All right, so let's make a couple of assumptions because this is the fun part. I am assuming that you're watching this session because you are probably very dedicated to, we'll call it ye old ASP.NET. See what I did there, Matt? So I'm assuming you're using probably anything .NET 3.5 or older. And in a best case scenario, you're probably .NET 4.5 or 4.6, 4.7, 4.8 when that drops eventually. But you're heavily invested in this older version of ASP.NET. And you've come to the realization that what's the future of not just ASP.NET, but .NET in general. And the guidance coming down from Microsoft is that with the release of .NET Core 3.0, which is inevitable, it's like they have a major conference coming up soon that they might release something. But the guidance says that with .NET Core 3.0, all greenfield development should probably be done on Core. That the .NET Full Framework is going to be mostly bug fixes and maintenance, but we're not going to see any new features from it coming down the line. So if you're coming in and you're trying to future-proof your application, you are looking at a jump to .NET Core. And if you've never done anything with .NET Core or ASP.NET Core, what do you need to know to make that jump? And I've done enough applications. I've kind of come up with 5 tenets that I think are reasonable for any existing ASP.NET developer to get their head wrapped around before they make the jump into ASP.NET Core. So we'll go through them one by one. Since I'm not in front of a live audience, like not physically in front of a live audience, this might go a little bit faster than it does in person. But again, if you have any questions at all, drop them in the chats. So number one, we need to say goodbye to our friend IIS, and we need to say hello to our new friend Kestrel. So let's just do a quick recap. When you built applications on ASP.NET, and I have ASP.NET 4.5 here, but really we mean go back to the beginning of ASP.NET. If you're still running ASP.NET 2 applications or 3 applications, you're probably running those on top of IIS because it makes sense. You build your ASP.NET app, you deploy to an IIS instance, and it's just there. And I always like to ask ASP.NET developers, how does an ASP.NET app get bootstrapped? How does it get started? It's not like it's an icon or an exe on your disk that you can just click on and run. There's a process to it, and that whole process happens through an IIS event HTTP handler that knows how to take requests coming from the internet, process them, and then sends them off into ASP.NET applications to get some results back. So all of this goes through IIS. It's the only way to run an ASP.NET application. Now I know what you're saying, Kevin. There are ways to run an ASP.NET application outside of IIS, but we're not going to talk about that because good luck getting that to work the first time. I've tried to do it several times myself. It's just not a fun process. Most folks just use IIS with ASP.NET because it's the path of least resistance. So again, IIS was responsible for all requests coming in, and our applications running in ASP.NET were responsible for the responses get sent back out. And this was nice because IIS would handle a lot of the crud that comes with being a web server. It would worry about if I was blocking IP addresses. It would do automatic backlogging of requests. So if my server was getting bogged down by just a slew of incoming requests, it could handle keeping those requests ready and available until my application was ready to handle them. It did a lot of really good things for us. But we were stuck on Windows. I mean, nothing wrong with Windows, don't get me wrong. But in this great world of Docker and Linux and cross-platform applications, being stuck on Windows kind of sucks because you have no flexibility. It's Windows or nothing. Let's contrast that with ASP.NET Core, where you have Kestrel. And Kestrel came out of the just necessity. Because IIS runs on Windows, you cannot run it on Linux or Docker or Mac or any device that supports .NET Core. So the ASP.NET team had to invent their own web server specifically for cross-platform applications. And that's where Kestrel came from. So any environment you can run .NET Core, you can run Kestrel and obviously run ASP.NET Core applications. It handles processing requests directly, and it's really good at being it can be your front-facing web server if you want it to be. I see a lot of folks that still put it behind IIS if you're running on Windows. If you're running on Linux or on Docker, you might put Nginx or something in front of it as well. But Kestrel by itself could be your outward-facing web server. And its whole process is taking those requests in and shooting them over to your app, or basically it's already in your app. Your app handles it and sends back a response. And it runs across anything that supports the .NET standard, which is really, really useful. But because we're not running on IIS and we don't have something coming in to bootstrap our application, we have to do a little bit of bootstrapping ourselves. So any ASP.NET application you get is going to have a program, specifically with a main function in it. And you go back to your early days of learning C# or C++ or anything, main means that's our entry point. We're coming in to the application and we want to do something. It's very obvious where the program starts. And our application here starts with create web host builder. And that's just a generic function that the ASP.NET team created that sets up all the CRUD necessary for running a web application. So you notice here that I don't have a thing to point at the screen, so I'll use my cursor. We have create default builder, and it takes in the command line arguments from the application. What does that exactly do? Well, I can go and show you. So there's a lot of stuff that happens in here. It says working directories, configuration, logging, actually a lot more than that. But it's more useful for me to just show you the actual GitHub repo because all the code for ASP.NET Core is available on GitHub. So let me bring over a new browser window. And I've been using Edge, the new Edge running on Chromium, and it is really nice. So if you haven't made the jump over to the new Edge, this is the dev build. I highly recommend it. It works fantastic, and it's not as heavy as Chrome is. So we're here inside of WebHost. Let's go down and search for create default builder, which is somewhere down here in the bottom. Yep. And you can see all the stuff that happens when you need to bootstrap a web application. We set our working directories, we set up configuration, So configuration not just being a config file, which you could have app settings. You have app settings for your particular environment. You could pull in user secrets. You can pull in environment variables. You can even send in configuration from the command line, and all that's already done for you. Set up logging not to the console, just the console, but also the event viewer. And then there's other things that configure Kestrel. It can configure Kestrel to run behind IIS. And even if you're running on Linux, it still does that check to see, well, if IIS is there, let's use it. If it's not, let's just ignore it. So it sets up all this work. And if you're coming to ASP.NET Core now, this is like, well, that's a lot of work. Well, a couple iterations ago, year and a half, 2 years ago, we had to write all this ourselves. It wasn't given to us as a part of the platform. All the bits and pieces were there, but they weren't abstracted into their own method that gets called for you automatically. I remember a number of times where I had to go look up, all right, I need to do this, this, and this. It wasn't by default and it wasn't obvious. But now it is. All right. So lots of stuff happened. All right. So normally I would do a demo, just .NET new. But you know what? I'm still going to do that. Because what I like to do is show this off. I had a lot of people in my my code stock talk that said, I have never seen .NET new, and can you please show me what that looks like before we start getting into some deeper stuff? I said, sure. So I'm going to do it here just in case there's someone out there watching who hasn't seen a demo of .NET new. So at the command line, or you could do this inside of Visual Studio. The processes are pretty much the same. .NET New will give me a list of all the templates that I have installed. And think of this a lot like the Visual Studio Create New Application Wizard. You go in there, there's lots of icons, and there's a lot of different settings. So we could choose something. Notice we have a lot of ASP.NET types here. Core empty, core web app, core Angular, core with React, React and Redux. And this is just what you get out of the box. You could go and download other ones if you wanted to. You could build your own. It's really easy to do. For our purposes, I'm going to create just a ASP.NET Core empty app. So .NET New, empty. I'm sorry, web. And we'll just do it in this working directory. So that creates a scaffold of the files that we need. It does a .NET Restore, which is installing NuGet packages that were default in the template. It shouldn't take that long. We'll open it in VS Code, but you could also open it in Visual Studio 2019 or 2017. I really like VS 2019. I've been using it for the past couple of weeks as my main Visual Studio. It works really well. And let's see, I don't have a good zoom on here, but let's do a quick zoom in. All right. Oh, that was a mistake. There we go. All right, the zoom's not working in my my screen share, so sorry about that. So you get a couple things out of the box here. You'll see Program CS. So I'm going to bump up the font real fast. This is what I showed on slides. We create our new web host builder. It gives us all the defaults, and that bootstraps the application. The second part of this bootstrapping process I didn't talk about yet is use startup, which I don't think is new for a lot of folks. If you're coming from .NET or ASP.NET 4 or 4.5, you have seen a startup file before. This was added, it's been years, but it was added to start to slowly start pulling the ties to certain utilities being tied directly to ASP.NET. So they could be used in other types of platforms. Well, that idea has rolled over into ASP.NET Core or .NET Core. So we have a startup file. And we should talk about what the parts of this startup file are for, because this is the second biggest place that I see people getting hung up, because they see two different methods: configure services and then just configure. We're going to actually jump back in the slides because I want to talk about configure services as its own thing, and then we'll come back and talk about configure as its own thing. So when you talk about configure services, we need to talk about dependency injection. And this is the next big fundamental jump for people coming into ASP.NET Core from older versions of ASP.NET. So in ASP.NET 4.5, you could do dependency injection, but it relied on external libraries. I was a structure map guy, but I also implemented solutions using inject and autofact and what's my Microsoft one, like Castle Windsor. There was a plethora of IOC containers out there that you could pull in and you could use them. But the fundamental idea was you didn't want to couple your applications to different implementations. You wanted to give yourself some flexibility. And more importantly, you wanted to give your framework the ability to change out implementations based off of different conditions. So when we use these different libraries, we had to go do all the configuration ourselves. I remember with Structure Map, anytime I created a new ASP.NET application, I would install Structure Map, but then I would also go install the scaffolding to configure Structure Map in ASP.NET, because that wasn't one line of code. It was more like 3-4 dozen lines of code to get the base implementation. And then I had to go add more to it as I created dependencies that I wanted to link inside of my IOC container. That was just a very long, drawn out process. And it was different on every project. I had 3 or 4 consulting engagements where one was using Structure Map, 2 were using Inject, and I think there was another one with Autofact or Castle Windsor. Which means you could understand the fundamentals of how dependency injection and IOC work, but you had to learn different syntax, different rules. They had different opinions, and it was a cluster going into these apps because you had to shift your mind and spend a lot of time in the documentation because you would just forget everything. Let's talk about ASP.NET Core then. In ASP.NET Core, everything's baked in. Dependency injection is a first-class citizen in the framework. You don't have to install external libraries. You could, and I'm pretty sure there's a workflow for doing that. But my big recommendation is that you just use the stuff that's built into the framework itself. And there's a lot of dogfooding. Any the services that you use that are built on top of ASP.NET Core. I have SignalR and Identity and such and such as good examples. They all support dependency injection at their core level, which means, let's say you have a difference of opinion. The ASP.NET team, they are amazing, and they do a lot of things right, but sometimes their default might not be the default that I want to use. Now let's use identity as an example. Maybe I don't want to use EF Core for any of my implementations. I want to write my own identity providers and run them through identity, which means I have to write implementations of several of their interfaces. But then with a couple lines of code, I can tell identity, instead of using your implementation, use my implementation. And it's pretty straightforward, and it just works as long as my implementations work. But it's nice to have that flexibility at the framework level. All right. And if you wanted to have dependency injection, I don't know why I have CI in here, but DI works outside of ASP.NET Core as well. If you're building a console application or some sort of service that's built on top of .NET Core, and you really want to use the dependency injection stuff that's built into the framework, you can pull that over. It's not tied to just ASP.NET. Let's see. I have a question in the chat. Which existing IOC framework is closest to ASP.NET's core's opinion? Oh, that is a great question, and I don't think I have a good answer to that. It's been a while since I've used some of the other frameworks. At really first glance, I don't think any of them make it as simple as ASP.NET Core does. And that's probably a good pro and con. Is if you are used to some of the weird, crazy injection things you could do with, say, a structure map or an inject, you probably don't have that same flexibility in ASP.NET Core. With ASP.NET Core, your sole intention is if any constructor or any service requests I of blah, then give them a this or give them a that. And you could also do concrete classes and all that good stuff. But I actually have an example which might explain it a little bit better. So again, here's our startup class. This has no content in it yet. This is what you get out of the box. And we're going to talk about configure services. And if you read this code, it's a bare bones nothing ASP.NET application. Any URL that you hit is just going to return hello world, because we say on a request, write back hello world. So you ask for index.html, you get hello world. Ask for fave icon, you get hello world. Ask for API/users, you get hello world. It's all coming down that same pipe. Well, obviously, your application is not going to be this simple. You want to use something like ASP.NET MVC. Well, how would we add that to an empty ASP.NET Core application? Well, it's done with some injections. The first is in our configure services, we add MVC. And what that's going to do is it's going to go through and set up all the dependency injection relationships for MVC. So MVC might need a controller factory, or it needs to handle responses, or it needs to do compression. It's all this stuff that MVC might do as a framework. Well, those are all abstracted into I of this, I of that, I of something else. And then they have implementations. Default, and this is probably not what it's called, but controller factory or default controller factory, so on. Well, when we say add MVC, all these relationships are going to get configured. And afterwards, I can go override those if I want to, but I don't have to. I can just use all the defaults, and most people do. Well, that just sets up dependency injection. The next thing I want to do is I want to add MVC into our routing pipeline, which we're going to talk more about in a moment. But that's what use MVC does inside of configure. So think about it this way. Configure services is just setting up dependency injection. Configure sets up routing and routing pipelines. Well, let's show you a different example using some of our own code. Let's imagine a case where I have a controller and my controller needs to access a user repository. And notice I'm passing an I user repository because I don't know where that user repository exists. My controller shouldn't care where that user repository exists. All the controller should care about is when I ask for get users, I'm expecting back a list of users. Well, in my controller constructor, I'll tell it, pass me an instance of an I user repository. And I'm going to save that away so I can use it later. What does I user repository look like? It is just an interface that returns a list of users when you say get users. Well, I can write implementations of that interface. So here, if I'm just testing some stuff out, I'll create a fake user repository. Now, there are entire mechanisms for creating fakes and mocks and all that good stuff. I'm not going to go down that rabbit hole. I'm just using an example. If you need a hard code, a fake user repository, it's as easy as returning a hard list of items. So a fake user repository implements the interface and just returns a handful of names. Awesome. Now, how do I tell my ASP.NET Core application that when I ask for a user repository to give me a fake user repository? Well, it happens again back in our configure services method. So before, where I told it to add MVC and it creates all the MVC injections, I can tell it to create my own injection. Now, I tell it to add in singleton relationship, that whenever I ask for an iUser repository, provide a new instance of a fake user repository. If you don't know your design patterns, singleton means it's going to create one instance of that user repository for the entire lifespan of my application. So the only way it goes away is if your application crashes, which I know your applications don't crash. Mine do all the time, but yours don't. So you don't have to worry about that. But if your application crashes, then it goes away, obviously. Or if you close it. So if you shut down or restart the process, then that instance goes away. So it's going to create one. It's going to get reused all over the place. But there's other types of rules that we can use inside of ASP.NET Core to define our relationships. Now, I already talked about singleton. We create one for the lifetime of the application. The next most common one that I see in ASP.NET Core applications is add transient, which means we're going to create one instance per instantiation. Oh, think about it this way. I ask for iUser repository, but I might need iUser repository in a dozen other areas of my application for a single request. Well, that means I'm going to get several different instances of fake user repository everywhere that it's requested, which could make sense. If you're scoping to a database connection and you want to just quickly open it and then close it, you don't need to leave these instances lying around. You can just quickly open and close them and get rid of that memory. But if you have other cases where maybe something like maybe like a Redis or a Mongo would be a good example, where it's better to not create a new instance every single time you need to use it. You create one instance and it's just long living for the life of the application. Add transit, it wouldn't be the best solution. You would probably look at a singleton or maybe adding a scoped instance. So when you say add scoped, it's going to give me one iUser repository that's used for the entire request. So a request comes in from the outside into our server, but I have half a dozen places that need an iUser repository. Well, they'll all get the same instance of iUser repository. And then once the request is done, a response is sent, that instance gets recycled. So that's really cool that if you want to scope an implementation to a request, so I'm trying to come up with an example off the top of my head, but I'm not. But if you wanted to create an instance and just have it live for the request, maybe it's tied to some sort of context ID, so you can relate everything to everything else. That might be a use of scoped. All right. Now, once you have dependency injection kind of figured out, you get into routing. And this is the next big leap for a lot of people coming into ASP.NET Core. Now, when we configure our services, it sets up a dependency injection, and then we have configure. And configure is where your request pipeline is going to get set up. If you've ever done anything with Node.js, maybe Express or Happy, you have seen that it's a top-down approach. When a request comes in, we're going to check all these rules to see if our request matches any of those rules. And if they do, it will handle it. If it doesn't, it passes it on to the next rule. let's use the base implementation here as an example. But let me mark it up a little bit more so it makes a little bit more sense. Configure can be read like a story. There's a narrative that happens. When a request comes in, we'll check to see if we're in development mode. If we are, we're going to add a little event handler that says use if the final response to this request is a 400 or 500, or more in particular, if our request throws an exception, we want to handle that exception and return the frowny face of death is what it is in .NET Core. It's nice, it's familiar, it gives you information, and that's really what we're looking for. And I'll show you the GitHub implementation of this here in a moment. All right. So the next thing we'll do is we'll go use MVC. This really pipes us into the MVC route handler. So if you've done anything with MVC in older ASP.NETs, you kind of already understand how that works. We'll talk more about it in a moment. But let's go through MVC. If MVC says I can't handle this, it will pass it on to the next thing, which is SignalR in this case. So SignalR will say, well, does it match the criteria that I know, which is really just one hub? If it does match, it goes off into SignalR stuff. If it doesn't, it comes back and returns a 404. So this particular method can get very long as you keep adding stuff to it. And there's at least two more cases where we'll add stuff to this file, and you'll see the narrative start to build. For a moment, I want to talk about MVC routing in particular, because most folks are coming over from an ASP.NET MVC background. And if you're coming over, you're already familiar with attribute-based routing. At least I hope you are. And it's the idea that you can decorate any controller action with route. And that will tell MVC that when the path from the URL matches this criteria, then execute this action. And you can make it a little bit smarter too by telling it what verbs to handle. HTTP get, HTTP post, put, delete, etc. And those are not new. If you've done MVC and MVC 4.5, you've done this before, hopefully. If not, it's you learn something new. You can even get smarter with it. You can just say, instead of route and then HTTP get, let's just do HTTP get. And the things in quotes are the path. So notice how I have just empty string. That's just default path, meaning I've gone to my browser and said localhost something something / nothing. This is the default path for anything coming in. You can also set up prefixes. So if you have an entire class or controller that needs to be served under users, you can say at the very top, anything under here will start with /users. And then you can create your multiple methods. So I have a get and a post method that both point to the same URL. /users, but one handles get requests, the other one handles post requests. So this is, again, nothing new. You could do this in older MVCs. I think if you go back to MVC 3.5, you had to use route prefix specifically. I think in 4 or 4.5, they fixed it where it's just route everywhere, and MVC will figure it out on its side. Now you could also, in older MVC, it was easier to do this, but you could set up convention-based routing, which means we have a convention. I can map a route, and MVC would automatically figure out, based off the pattern of the route, what the controller name should be, what the action should be, and what the ID, if any, should be. I have a personal opinion. Don't do this. It is harder to do it this way in ASP.NET Core than it was in older MVCs, which might be a trigger that you shouldn't do it this way. And I'll stand on that soapbox all day long. Don't do it this way. And unless you're moving legacy code over and it's harder to turn everything into attribute routing, then do it this way. But, yeah, I'm not a big fan of this. I'd rather just have my empty use MVC and do everything with attributes. Because you have to remember, convention means MVC is going to guess where your request should go. Attributes tells MVC where your request should go. I personally believe that is a better way to architect our MVC applications. All right. Some of you crazy people out there might prefer WebAPI style controllers and actions, which means I have a user's controller, but then a get, a post, a put, a delete method on them. And the name get, post, put, delete on the methods mean what they should handle. So in MVC for whatever, they call that map API routes. And you can still do that in core. I don't recommend it. But again, you can do that if you want to. Well, let's talk more about this difference between MVC and WebAPI in terms of ASP.NET Core. And I forgot to put my fancy animations on this, but in ASP.NET Core, there's no separation between a controller and an API controller in the same way there was back in the old ASP.NET days. So theoretically, a controller is a controller is a controller. If you want to do API stuff, you have a controller. If you want to return Razor views, you have a controller. It's simplified from that standpoint. When you're in the documentation, though, and on docs.microsoft.com, everything is still separated into MVC style functions and then Web API style functions, but they all derive from controller. The biggest change coming into this new controller are the return types. So notice on my index here, I'm returning an I action result. And it's not far off from what we were used to in ASP.NET 4.5, which would return just action results. But think of the I action result as more of an abstracted version of a result. Let me put up my example here. An I action result can be anything you want it to be. So here I have three cases. Return a view returns a view, which might be Razor or something else. Return OK returns just OK. This is pointing back to WebAPI. This is where we got OK from in the newer versions of WebAPI on legacy ASP.NET. And then I had other helpers like bad request. So something comes in and I didn't get the information in the right format, or I was expecting parameters that weren't there. I could return a bad request. This is a very fluent way to communicate in our code our intentions. And because we're dealing with controllers and web requests, we really need to take into account how we're talking back to HTTP clients. If they're expecting 200s, we should give them 200s, or the 400, 500 that would normally result in an error. If I'm creating a new object, I should return it created. And the nice part is the .NET team, the ASP.NET team, gave us a slew of built-in types. So whatever your common case will be, there's probably a built-in I action result to return that. In worst case scenario, you just return a status code and you pick the status code that you want. But I know a lot of you are coming from Web API and you're like, well, Kevin, I don't want to return just OK. I want to return my actual object. Well, you can return specific types as well. So because you're a controller, you could say, well, get user returns just a user. And get users returns a list of users. And you don't have to worry about the status codes or anything like that. ASP.NET is automatically going to say, all right, I'll return a 200 OK with the user as the payload, or the list of users as the payload. And this is really helpful for just getting your data out. So if you're making that transition from WebAPI on ASP.NET 4.5 to ASP.NET Core, you should almost be able to copy and paste that code or just drag that file into a new application and it should work. Your mileage might vary, asterisks. But I know what you're saying. It's like, well, Kevin, what if I call get user and I can't find the user? I don't want to return 200 okay. I want to return, was it 404 not found. I want to return something that's more legitimate because I want to be a good HTTP citizen. Well, how would you solve that problem with this code in older ASP.NETs? Well, there's a couple ways. You could return not just the user object, you could create an HTTP response message. Or I've seen this a lot of times, you could throw a new HTTP response exception. And you could say this is a 404. Well, you can't do that anymore. That's not in core. In fact, I wish I could find the tweet or the GitHub post where folks on the ASP.NET team, I think David Fowler in particular, said, we don't want you to control status codes using exceptions. That is an anti-pattern. Well, that means we're kind of in a bad place right here, because how do I handle my good result, which means I return a user, or how do I handle my bad result, which is a 404 or a 400 or even some 500 code? Well, there's a compromise between iAction result and just a specific type, and that's going to be action result of T. So best of both worlds. Yay. What if instead of returning iAction result or just user, I return action result of user or action result of IEnumerable user? This gives me the ability to return not just the object, if I find the object that I want to return, but I can also return any of the appropriate action results that we saw a couple slides ago. So you can do your proper conditions in your code, and you're being a good HTTP citizen, and you don't have to do anything fancy. All of it just works. All right. So wrapping this up, I want to talk about some other goodies that, for the sake of time, they don't really get their own slide. There's a couple slides altogether. The first is static files and www-root. So www-root, you might be familiar with if you have ever worked with IIS. It is the default location for a web application on an IIS server. Well, in ASP.NET Core, we have a folder underneath called www-root that we consider our public folder. But it's not public by default. We have to go in and turn it on. And that's done inside of our configure method. Remember, this is a pipeline. Well, let's walk through the narrative. All right, if I'm in development mode, let's listen for exceptions. If there's an exception, handle it with a nice page. If not, let's see, is this signal R? Okay. I took out MVC. I'm not sure why. Oh, well. But finally, I tell it, let's turn on default files. Default files, if you remember from IIS, are any file that we should use in the absence of a path. So if I just ask for localhost / nothing, well, what files should we look for by default? Index HTML, index HTML, default ASPX, go down the list. There's a bunch of them. Well, let's turn those on. So if there's an empty path, let's assume a common list of default files, or you can override those files if you like. And then finally, use static files, turns on the www-root folder, which allows us, at any worst case scenario, go look in that folder for an exact file path combination. If it exists, let's return it verbatim, which means if I have index HTML in my www-root and I ask for nothing, well, let's assume the default file index HTML. Let's see if it's in that folder. If it is, that's what gets returned. This is a great way for handling things like graphics, style sheets, JavaScript, you name it, put it in your www root and turn it on. It just magically works. And then finally, if it's not in that folder, we return a 404. And the next big common question with this approach is, what if someone out there is using a SPA framework like React or Angular or Vue? I've been doing a lot of work with Vue.js lately, and I've run into this problem numerous times. I want to have my SPA, my single page application, running in one place. I want to have my ASP.NET application running as a web service in another place, but I want to deploy like they're all one big happy family. How do you do that? Well, on deployment, it's easy. If you're going into production, you just run a production build of your Vue.js application, copy that distribution folder into www root, everything magically works. But in development, it's a little bit harder. In development, you want to have 2 running web servers, but you might not want to run 2 web servers in your browser. Well, one of the things you can do is you can proxy requests from one web server to the other. So in ASP.NET Core, we have this thing called SPA services and extensions, and I can tell my ASP.NET Core application that if the request comes in and it doesn't match any of the other defaults, let's proxy that call over to my Vue.js application, which is running on localhost 8080. And that means any request that comes into my app for index.html, for something.js, something.css, well, that's not going to exist in my www root, but it will exist over on my Vue.js web server. So if I proxy the call over to that web server, it will get the response and it funnels back out to my browser. This workflow means I can do all my development work using one URL, and it's a very happy experience. So, and I'll be truthful, this is something I learned about just a month or 2 ago, because I was running into this problem and I had seen solutions where folks were doing this same thing, but in reverse. So they were hosting their Vue.js application and then proxying all API calls to their web services. So .NET Core or Node.js or something like that. And that's fine. It works either way. I prefer this method. I think it's a little bit cleaner, a little bit easier to understand. And it's easier to configure .NET Core for this stuff than I think configure anything over in JavaScript land. But that's just me. The last big thing I'll talk about, I'm not going to really do a demo. This is Razor Pages. So this is a newer concept for folks coming from legacy ASP.NET. The fundamental problem with Razor is that to use a Razor page in ASP.NET MVC, you have to have a controller, you have to have an action, you have to do all this work, and that's just to scaffold the main app. All right, really, there's nothing wrong with that. But, remember back in web forms, if you ever did web forms, things were kind of easier. You could just go default.aspx in your browser, and it would find the file default.aspx on your machine, and it would render that, and it would just magically work. Well, what if Razor could work that way? Well, that's what Razor Pages is. Razor Page is basically a page without needing a corresponding controller in action. You could just create the Razor, and then you have a little bit of code behind in a page model, and it would just magically work. So if you go call up index, it loads that page. So I'll admit I've not done Razor Pages at all in production or development applications, but it's a useful tool to have in your pocket just in case you need some of that functionality. As we wrap up, there are a couple other things that I thought about as I was wrapping up this talk that was worth mentioning. but they don't get their own dedicated slides. Number one being performance. With .NET Core 3.0, I was seeing some crazy numbers. Like they said that .NET Core 3 will have like 80% reduction in memory usage, at like 30% increase in speed. I'd have to go look at the benchmarks, but I'm amazed by how performant ASP.NET Core is as a whole. It gets better and better to the point where I could just do a NuGet update and magically my application's faster. It's really impressive, really cool to see. The next thing is custom middleware. So we talked about routing. Do this. If that doesn't work, do something else, and so on and so on. You can write your own. So if you want to write your own handler that gets a raw request and does something with it, that's fundamentally really easy to do. And a lot of different add-ons take advantage of that functionality. I use Hangfire for some background processing. Their UI is custom middleware. It works pretty well. But speaking of Hangfire, I started using Hangfire because I needed background services in my ASP.NET applications. Because we've all had that need where, all right, I have something I need to do in the background, either on some sort of trigger or on some sort of interval. And Hangfire handles that perfectly. But now it's fully supported in ASP.NET Core, where you can build background or hosted services that run independently of the requests coming in, and they can do whatever you need them to do. They have all the injections of your ASP.NET application, and it just magically works. Number 4, health checks. I was working on this today, actually. If you're using any sort of health monitoring system, or you have a variety of microservices or dependencies, and you just want to know if they're up and running like they should be, you can write health checks that will ping these different services. So I worked on an installation of this today where we needed to check a SQL server, a Redis server. We needed to make sure blob storage was accessible. We wanted to make sure that Hangfire was up and working and that all the servers that we expected in Hangfire were operational. We have a external web service dependency. We just ping that to make sure it's up and running. About 2 hours, I had all these health checks ready to go, and it was amazing. And it exposes a URL that gives you just healthy or unhealthy data. And you can tie that into something like application insights to get that data in. And maybe if you have an unhealthy node, you could send yourself an alert. If you're using something like Docker, health services are built into that as part of the orchestrator. There's a lot of uses of health checks, and it's a really cool feature that I had just played with, but I'm now using heavily in all my ASP.NET Core applications. And then finally, there's a variety of enhancements to the logger in ASP.NET Core, where you can just inject the logger everywhere and it will log wherever you need it to. So the console or to somewhere on the disk or to event viewers or to things like application insights. I've seen people write their own for a variety of logging services. So just a really cool thing to mention is some of the changes to the logger in ASP.NET Core. But with that, I'm right about out of time, and I'm open to any questions that anyone out there in Webinar Jam or on Twitch might have. If not, hit me up on Twitter or on email. I would love to talk to you. And thank you all so much for hanging out with me today. So I'll give it a moment, knock my screen down. All right, folks on Webinar Jam can just see my pretty face. Here, I'll move that over there. All right, folks on Twitch see a little bit of everything. All right. Well, cool. Well, I don't see any new questions coming in. So we'll go ahead and cut it off there. Thank you all so much for hanging out with me today. Keep an eye on the SwiftKick channel on Twitter at Team SwiftKick for new and upcoming SwiftKick shows. If you're in the Webinar Jam, you'll get an email about it, or keep an eye on Twitch because we'll be co-broadcasting there as well. Thank you all so much. I will see you next time.